All right, okay. So this connection change was such a big deal, really. We worked really hard on it and took it super seriously. And what we have to keep in mind is the Titan 1 was designed at a time where we only had aluminum foils, fuselage and masts, and that geometry was actually designed around aluminum material. And when we introduced the carbon mast later on, we used that same connection, and it was already quite a challenge to make it work with carbon because it's not super suited for that. And so the question of changing that connection actually came back on the table numerous times along the years, and we really tried to do everything we could to every other thing than changing the connection, basically pushing every corner, every inch, leaving no stones unturned. So we worked on the screws, we worked on the layups, we worked on the inserts, we worked on all the aspects that we could to push the performance of that T1 connection to the max. We had reached a point where the feedback from the riders were consistent and the connection had become the weakest link, and it was preventing the riders from using the full potential of the wings. Like, we could make better front wings or better tails or better mast, but at some point you could not use that full potential because the connection was not stiff enough and also sometimes not reliable enough. So that was really the trigger point where we've decided, okay, this means that now that change has become unavoidable.
The Titan 1 was a very good reference because it was very low drag, and making something that with a total connection achieving as low drag as the Titan 1 was very big on compromise between the structure and hydrodynamics. And so we worked a lot with Charles, going back and forth, iterated a lot, 3D printed stuff, doing CFD analysis on the size of the fuselage, doing a lot of testing on the water as well with the test riders. But once we've figured out the depths of the socket that we wanted, that was good in hydro and in structurally, we also developed the shape of it, so it was easy to manage, easy to assemble. And the least thing that we wanted was that we didn't want someone to take to the beach a mallet to remove our fold. So we wanted to have something that was pretty very stiff, but also manageable on a day-to-day basis. And so having something with like a swept angle and on the socket on all directions meant that we have something that you can't mistake the back and front, and also you can remove and assemble easily, and you don't have also with the angles vertically, you don't have a lot of wear compared to a vertical wall. So vertical walls, if you have a socket with a completely vertical wall, you have a lot of wear because the part on the mast and the part on the fuselage will scrap a lot, rather than if you have an angle, then you have something that is more progressive, and then you don't have a lot of wear compared to that. So it's easy to remove and also more durable in a long time.
Very early on, from the first versions we had, the feedback from the testers was clearly that they could ride higher, with a foil closer to the surface, and which always indicates a stiffer connection. So globally, when your foil is more secure in terms of stiffness, you can always ride a little bit higher, and that means less drag and basically more potential for you to use out of your foil. So The stiffness was always there with that new connection, and means your pumping is better, your control is better, your turns are better, all thanks to this increased and improved stiffness. And we had then to work on the hydro side too, because there was a few downsides at first, and this was all fully compensated with the number of iterations we did and the small tweaks that we made on the shape to really nail, you know, a high-performing low drag and section. And also something we did not suspect at first is how important the fuselage is for the maneuverability. And this is also something that we worked on to guarantee the same level of maneuverability, basically.